When extending an existing 20 amp circuit for lighting, the question of whether to use 12/2 wire throughout or transition to 14/2 wire at the lighting point often arises. The answer lies in understanding the ampacity, which is the current carrying capacity of each wire gauge, and adhering to electrical code requirements. You can indeed add 14/2 wire to a 20 amp circuit specifically for lighting, provided the total load in the circuit does not exceed 20 amps. The rationale behind this centers on the National Electrical Code, or NEC, which permits the use of smaller gauge wires for specific portions of a circuit if the overall load remains within the capacity of the overcurrent protection device, typically a circuit breaker. The 14/2 wire is typically rated for 15 amps. This means that it can safely handle a continuous load of up to 15 amps without overheating. The 12/2 wire, commonly used for 20 amp circuits, has a higher ampacity, typically around 20 amps, or even 25 amps or more depending on installation conditions and temperature ratings. When adding lighting to a 20 amp circuit, the critical factor is calculating the total amperage draw of all devices and fixtures connected to that circuit. This calculation must include existing loads in the circuit, as well as the new lighting load that is being added. To determine if the 14/2 wire is suitable for the lighting extension, add up the amperage of all lights and any other devices that will be powered by the 14/2 portion of the circuit. This can be done by checking the wattage of each light or device. Then, divide the wattage by the voltage, which is typically 120 volts in residential applications, to find the amperage. For example, a 100-watt light bulb on a 120-volt circuit draws approximately 0.83 amps, as 100 divided by 120 equals 0.83. If the total amperage of the lighting, plus any other loads on the 14/2 portion, is less than or equal to 15 amps, then the 14/2 wire is acceptable. However, remember that the entire circuit protected by the 20 amp breaker must not exceed 20 amps total, combining the loads on both the 12/2 and 14/2 portions. It is also very important to consider inrush current, which is the momentary surge of current that occurs where a device is first turned on. This is especially important for LED lighting and electronic devices, as they can have higher inrush currents than traditional incandescent bulbs. Although the running amperage may be low, the inrush current could potentially trip the breaker or damage the wiring if it is not accounted for. To address inrush current concerns, it's advisable to use lighting fixtures and devices with lower inrush current ratings. Another approach is to slightly over-engineer the wiring by using 12/2 wire even for the lighting extension. This provides an additional safety margin and reduces the risk of nuisance tripping of the circuit breaker due to inrush current. Firstly, if the existing 20 amp circuit already has a significant load, such as multiple outlets or appliances, adding more load even if the lighting is less than 15 amps on 14/2 wire could easily push the total circuit load over the 20 amp limit. In this case, it is not safe to add the 14/2 wire. Secondly, it's also essential to ensure that all wiring connections are made correctly and securely. Loose connections can cause arcing, which can generate heat and potentially start a fire. Use appropriate wire connectors, such as wire nuts or terminal blocks, and ensure that they are properly tightened. Thirdly, consider the type of lighting fixtures being installed. Some lighting fixtures, such as recessed lighting, may have specific wiring requirements or limitations on the type of wire that can be used. Refer to the manufacturer's instructions and local electrical codes for guidance. Here are some things to keep in mind. Always turn off the power to the circuit before working on any electrical wiring. Use a voltage tester to verify that the power is off. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician. Ignoring these safety precautions can lead to electric shock or fire. The 14/2 wire must be properly grounded. This means connecting the ground wire in the 14/2 cable to a grounding point, such as a metal junction box or a grounding screw on a receptacle. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker in the event of a short circuit or ground fault. The NEC specifies the types of wiring methods that are permitted for different applications. Make sure that the wiring method used for the lighting extension complies with the NEC and local electrical codes. For example, the NEC may require the use of conduit or armored cable in certain locations. If you are unsure about any aspect of the electrical work, consult with a qualified electrician. They can provide guidance on proper wiring techniques, code compliance, and safety procedures. A permit may be required for electrical work. Check with your local building department to determine if a permit is needed before starting the project. Obtaining a permit ensures that the work is inspected by a qualified electrical inspector, which can help to identify potential safety hazards and code violations. The wire gauge is a critical consideration when extending an electrical circuit. While 14/2 wire is permissible for lighting on a 20-amp circuit under specific conditions, it's essential to understand the limitations and safety implications. If the total load in the circuit, including existing loads and the new lighting load, exceeds 20 amps, then 14/2 wire is not suitable. In such cases, it is necessary to use 12/2 wire, which is rated for 20 amps throughout the entire circuit. When evaluating the suitability of 14/2 wire, it's crucial to account for the continuous load in the circuit. The NEC specifies that the continuous load on a circuit must not exceed 80% of the circuit's rating. For a 20-amp circuit, the maximum continuous load is 16 amps, as 20 amps multiplied by 0.80 equals 16 amps. If the existing continuous load in the circuit is already close to 16 amps, adding additional lighting load, even if it's less than 15 amps on 14/2 wire, could exceed the 80% limit. In this case, it's advisable to use 12/2 wire for the lighting extension to provide a greater margin of safety. To ensure code compliance, it's essential to consult the NEC and local electrical codes for specific requirement. These codes provide detailed guidelines on wiring methods, conductor sizes, overcurrent protection, and other electrical safety aspects. They also outline the specific conditions under which 14/2 wire can be used on a 20-amp circuit. If there are any doubts or uncertainties, it's best to seek guidance from a qualified electrician or electrical inspector. In some cases, local codes may be more restrictive than the NEC, so it's important to be aware of the specific requirements in your area. A key consideration when using 14/2 wire for lighting is the type of lighting fixtures being installed. Certain types of lighting fixtures, such as recessed lighting, may generate more heat than others. This can affect the ampacity of the wire and potentially create a fire hazard. When installing recessed lighting, it's essential to use fixtures that are insulation contact, or IC, rated. These fixtures are designed to be installed in direct contact with insulation without overheating. It's also important to follow the manufacturer's instructions for wiring and installation. The length of the wire run is another factor to consider. The longer the wire run, the greater the voltage drop. Voltage drop occurs when the voltage at the end of the circuit is lower than the voltage at the beginning of the circuit. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to run inefficiently. The NEC provides guidelines on voltage drop. It recommends that the voltage drop on a branch circuit should not exceed 3%. If the wire run is long, it may be necessary to use a larger wire gauge to minimize voltage drop. When connecting the 14/2 wire to the 12/2 wire, it's essential to use appropriate wire connectors. Wire connectors, such as wire nuts or terminal blocks, are designed to provide a secure and reliable electrical connection. They also help to prevent corrosion and arcing. It's important to choose wire connectors that are rated for the wire gauge and the number of wires being connected. The NEC specifies the types of wire connectors that are permitted for different applications. Proper grounding is crucial for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker in the event of a short circuit or ground fault. The 14/2 wire must be properly grounded by connecting the ground wire in the 14/2 cable to a grounding point, such as a metal junction box or a grounding screw on a receptacle. The grounding system must comply with the NEC and local electrical codes. If the existing circuit does not have a proper grounding system, it may be necessary to upgrade the grounding system before adding the lighting extension. Before starting any electrical work, it's essential to turn off the power to the circuit. This can be done by switching off the circuit breaker that supplies power to the circuit. Before touching any wires, use a voltage tester to verify that the power is off. A voltage tester is a device that detects the presence of voltage in a wire. If the voltage tester indicates that there is no voltage, it is safe to proceed with the work. Never assume that the power is off. Always use a voltage tester to verify. Electrical work can be dangerous. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician. An electrician has the training and experience to perform electrical work safely and correctly. They can also ensure that the work complies with the NEC and local electrical codes. Attempting to perform electrical work without proper training and experience can lead to electric shock, fire, or other hazards. The NEC provides tables that specify the ampacity of different wire gauges under various conditions. These tables take into account factors such as the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. When determining the ampacity of a wire, it's essential to consult these tables and use the appropriate ampacity rating for the specific conditions. Using a wire with an insufficient ampacity can lead to overheating, insulation damage, and potentially a fire. The type of insulation on the wire is also an important consideration. Different types of insulation have different temperature ratings. The temperature rating of the insulation indicates the maximum temperature that the wire can withstand without degrading. It's essential to choose a wire with an insulation temperature rating that is appropriate for the application. For example, if the wire is being installed in a hot environment, such as near a lighting fixture, it's necessary to use a wire with a higher temperature rating. Some common types of insulation include thermoplastic high heat-resistant nylon-coated, or THHN, thermoplastic heat-resistant water-resistant, or THWN, and cross-linked polyethylene, or XLP. The NEC specifies the types of insulation that are permitted for different applications. In addition to the wire gauge and insulation type, the wiring method is also an important consideration. The wiring method refers to the way in which the wires are installed and protected. Some common wiring methods include conduit, armored cable, and non-metallic sheath cable. The NEC specifies the wiring methods that are permitted for different applications. The choice of wiring method depends on factors such as the location of the wiring, the type of building construction, and the environmental conditions. Conduit provides the best protection for wires, but it is also the most expensive and time-consuming wiring method to install. Armored cable is a flexible metal conduit that is easier to install than rigid conduit. Non-metallic sheath cable, or ROMIX, is the most common wiring method for residential wiring. It is relatively inexpensive and easy to install, but it is not as durable as conduit or armored cable. When extending an existing circuit, it's important to consider the existing wiring method. If the existing circuit is wired with conduit, it may be necessary to extend the conduit to the new location. If the existing circuit is wired with non-metallic sheath cable, it may be possible to extend the cable to the new location. However, it's important to follow the NEC and local electrical codes for splicing and extending non-metallic sheath cable. Splicing is the process of joining two or more wires together. The NEC specifies the methods that are permitted for splicing wires. Wires should be spliced in an approved junction box, with the correct connectors for the wires used. It's never acceptable to simply twist two wires together and tape them, as this creates a dangerous and unreliable connection. The NEC also provides guidelines on the size and location of junction boxes. Junction boxes must be large enough to accommodate the wires and connectors. They must also be accessible for inspection and maintenance. When installing a new lighting fixture, it's important to follow the manufacturer's instructions. The manufacturer's instructions will provide detailed information on the wiring and installation of the fixture. It's also important to ensure that the fixture is properly grounded. The grounding conductor from the lighting fixture should be connected to the grounding conductor in the junction box. If the junction box is not grounded, it may be necessary to install a grounding conductor from the junction box to a grounding point, such as a metal water pipe or a grounding rod. Before energizing the circuit, it's important to inspect all of the wiring and connections. Make sure that all of the wires are properly connected and that all of the connections are tight. Also, make sure that all of the junction boxes are closed and that all of the covers are securely fastened. Once you are satisfied that all of the wiring and connections are correct, you can turn on the circuit breaker and test the lighting fixture. If the lighting fixture does not work, turn off the circuit breaker and recheck the wiring and connections. It's also important to label the circuit breaker that supplies power to the lighting fixture. This will make it easier to identify the circuit breaker in the future if you need to turn off the power to the fixture. A label maker can be used to create a label for the circuit breaker. The label should include the location of the lighting fixture, such as living room lights. Adding the lighting circuit safely needs you to do all of these steps carefully.